Hey, what's going on, guys? Let's do this problem right here. The first question, it's asking when two or more capacitors are connected in the parallel across a potential difference. The first statement says the equivalent capacitance of the combination is less than the capacitance of any of the capacitors. So here the key word is parallel, right? So this statement is true if it's in series. So whenever we have capacitance in series, the combination of the equivalence capacitance is going to be always lower than any of the capacitance. But for parallel, it's not true. So this is a wrong statement. Let's look at the second statement. Each capacitor carries the same amount of charge. Again, this is true for the series because the whenever we have capacitors in series, the charges are equal, but whenever this is in parallel, this is not equal. So this is also wrong. Let's look at the third one. The potential difference across each capacitor is same. This is true because in parallel series, this is the potential difference is going to be same across the capacitors. So this is the correct statement for this question. Therefore, answer is C. Let's look at the second question. An air-filled parallel plate capacitor has round plates and carries a fixed amount of equal but opposite charges on its plates. All the geometric parameters of the capacitor, plate diameter and plate separations are now doubled. If the original capacitance was C0, the new capacitance is what? So that's the question. So let's see how we can find it. So first of all, initially, when we don't change anything, the capacitance equation is going to be epsilon naught A over L. So this is the capacitance equation, A over L. And in terms of, if you want to write in terms of diameter and length, it's already written in terms of L. Let's write this one in terms of diameter. So we know that area, the cross-sectional area is going to be a circle. So here the area is going to be area of a circle. We know that area of a circle is pi r square. If you want to write in terms of diameter, it's going to be phi d square by 4, right? Because d by 2 is the radius, so d by 2 square is going to be d square by 4. So this is going to be the area of a circle. So let's replace this one by this. So this is going to be epsilon naught phi d square by 4L, right? So this is going to be the initial condition when we don't change anything. So let's see what happens when the plate diameter and plate separation are doubled. So when we double the plate separation, when we double the diameter, the new diameter, before we had d by 2 is the radius. Now we are going to have d as our radius. When we multiply this one by 2, this is going to be just d. So the new area is going to be just phi d square, right? So this is going to be the new area. So we can write this one as epsilon naught phi d square. And in the bottom we have length. So they are saying plate separation also doubled. So this is going to be doubled in the denominator. So this is going to be times 2 times L, right? And if you compare these two, if you multiply this one by the initial one by 2, you will get this one. So we can go ahead and say this is equal to 2 times initial one. So that's going to be C prime is equal to 2C0. So 2C0 is going to be the answer. So at final we have 2C0. So the answer is C. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.